Hello students, welcome back. I am Arijit sir. Today in our organic name reaction, we are going to learn about the Oppenauer oxidation. Okay, so students, what is Oppenauer oxidation? It is actually the secondary alcohol on refluxing with acetone in presence of catalyst amount of say for example aluminum tertiary butoxide are oxidized to ketones, okay, while the acetone is reduced to isopropyl alcohol like this. Say this one is our one of the secondary alcohol, and this one in presence of acetone and aluminum tertiary butoxide actually this aluminum actually becomes this one becomes the ketone, and this ketone becomes the isopropyl alcohol. Okay, now what happens here actually, this tertiary butyl alcohol on the other hand is resistant to oxidation, and this is known as Oppenauer oxidation, this process. Okay, now I'm going to show you how this occurs in mechanism part. Okay, now let's see the mechanism. After that we'll give you some examples. Okay, now here in the first step, the removal of tertiary butyl group from the aluminum tertiary butoxide by the secondary alcohol. Okay, aluminum tertiary butoxide, I am writing it here as simply like this. Okay, so the first step, the removal of tertiary butyl group from the aluminum tertiary butoxide occurs. Okay, this is how. And this one forms the tertiary butyl alcohol. Okay, this is our tertiary butyl alcohol. Okay, now in the second step, what happens over here, form a complex which is actually reacts with the acetone. Okay, it actually forms the complex. See, this is our acetone. This is acetone, and here is our this is aluminum or tertiary butoxide 2. This is forms a transition state. Okay, TS state, transition state. Here in this case, this bond actually, this is the main step, attacks the carbon, and this forms the negative ion. Okay, here you can see this bond attacks the carbon and this negative ion, and then it attacks the aluminum, and then this bond breaks to form the double bond, and this is the actual mechanism occurs over here in this Oppenauer oxidation state. Now it forms, you can see, after that it forms aluminum or tertiary butoxide equal to, with that R dash R C double bond O, and this is the ketone that forms. Okay, and after that this one will be hydrolyzed. After hydrolysis, okay, and this forms the isopropyl alcohol. Okay, so this is the actually the formation step, how the tertiary alcohol forms. This is the main mechanism step. Okay, you can see this is the main mechanism step. Now I'm going to show you some of the examples. Okay, let's see. Now here you can see the first example I'm going to give you, diethyl carbonyl, actually this one. Okay, now reacts with acetone in presence of aluminum tertiary butoxide. It forms, this is diethyl ketone. Okay, and isopropyl alcohol with that. This is diethyl carbonyl. It forms the diethyl ketone. And another second example I'm going to give you, 2-ethyl cyclohexanol. Say for example this one is our 2-ethyl cyclohexanol. When reacts with benzoquinone in presence of aluminium tertiary butoxide, it produces 2-ethyl cyclohexanone. Okay, and then this our benzoquinone actually forms the hydroquinone. Okay, so this one is our benzoquinone and this one is 2-ethyl cyclohexanol. 2-ethyl cyclohexanol forms 2-ethyl cyclohexanone, and this benzoquinone converts into hydroquinone. Okay students, so these are the two examples, very good examples of Oppenauer oxidation. Okay students, and one thing is I'm going to tell you, Oppenauer oxidation is actually the reaction in this shifted to the equilibrium in the right side when it's get to the ketone, and this is the reverse reaction of Meerwein Ponndorf Verley reduction. Okay, where the carbonyl compounds, actually you can see the aldehyde ketones are reduced to the corresponding alcohols by the isopropyl alcohol in the presence of catalytic amount of aluminium isopropoxide. Okay, so this is the exactly opposite reaction of MPV. Okay, so students, I hope you like this video, and if you like it, don't forget to share with your friends and please subscribe my channel. Thank you students, have a nice day, goodbye.